Hello and good morning. Thank you for choosing to continue on with this class. It's good to see that you're here. The first week's lesson we're going to be talking about is section 8.1 in your book. If you don't happen to have your book, don't worry, you don't really need it. But this section covers area of triangles and some of those special quadrilaterals like parallelograms, trapezoids, and things like that. So the first question that I have for you is, what is area? And at this point the video is going to pause and you're going to have to type something in there. So think about what area is. The video will pause, and then once you've typed something in, you can continue on. So when we talk about area, what we're really talking about, I think a lot of you probably know the formulas for area more than you actually think about what area is in and of itself. So you've heard of things like area is base times height or something like that. But something to think about here is area, what it really is it's a measurement of how big a surface is. So if you have something like a rectangle or a circle, how much space does that shape take up? And that's what we're really trying to measure with area here. Now, one of the biggest things with area is instead of just using something like inches or centimeters, because we are trying to figure out how much space this takes up, an area or a length like 10 centimeters is only a one-dimensional unit. When we actually go and say how much area this is, we're actually measuring like there's little squares here. How many squares of 1 centimeter by 1 centimeter? How many of those squares would it take to fill up this whole box? That's what area is, and that's kind of what you want to be thinking about as we go through this. So, if you look at these shapes that we have here, I'm going to guess that most of you have seen the formulas for almost all of these. There's definitely some on here that you've never seen the formulas for. But for things like rectangles, parallelograms, maybe triangles, you've probably seen those before. So today, the biggest thing that I want to talk about is not necessarily what those formulas are. We'll definitely review those, but where they come from and how we use them. Those are things, the formulas themselves, there's no reason for you to memorize them. You probably know a few of them, but if you ever need to know how to find the area of a pentagon or a trapezoid, you can always look those up. They're a Google search away. So the first thing I want to do here is just talk about the simplest case here, rectangles, which also, of course, includes squares along with it. So if you ever see a rectangle or a square, these are the same formulas. And so this just goes back to thinking about what multiplication is. If I'm looking at how many of these unit squares there are on my rectangle, to figure out how many there are, one of the shortcuts besides just counting them up is to look at how many are there across, and then how many are there going up and down. And since there's 4 across and 6 up and down, to find out the total number of squares without counting them, I'm just going to take 6 times 4, and I know that there's 24 of those little unit squares. If these were in inches, then we'd have what we call square inches, meaning we have a square that is 1 inch long. By the way, I'm making symbols with my hands, even though you can't see me. And so our area formula here is just base times height. And that's probably one that you've seen before. Now, next up, we've got parallelograms. And parallelograms are just a little bit different than rectangles, but of course parallelograms include all of those rectangles as well. And it also includes things like rhombuses. If you need to find the area of a rhombus, you can use this formula as well. And so we've got the area formula here. Not really a secret. Again, you could look that up if you need to. Area of a parallelogram is base times height. Now the most important thing with parallelograms is what that height means. The height is always going to be measured perpendicular to the base. So if I'm using the 8 centimeters as my base, the 2 centimeters here, that's the height. The 3 centimeters, not useful for area. So when I'm going to find the area of this parallelogram, I always start by writing down my area formula, and then I'm just going to plug in the numbers that I know. I know the base is 8, I know the height is 2, so I know my area is 16. In this case, if it was centimeters, that makes it centimeters squared. Now, like I said, the biggest thing I want to look at today is where these come from. So I've got a little GeoGebra thing ready that shows you how to find or how to prove that this is actually the formula. So here we've got a parallelogram, and it's labeled base B and height H. And the easiest way to think about this is if I were to just cut this triangle off and move it to the other side, I would have a rectangle. And so at this point, the area formula here is pretty obvious. We've talked about that. It's the base times the height for a rectangle, and it has the exact same area as the parallelogram did before. And so the area formula has to be the exact same thing. Okay, next up we're going to talk about triangles. And so for our area formula for triangles, again, this is probably the one, if there was any on here that you knew, I'm going to guess triangles and rectangles are the two that you knew. The area formula here is 1/2 base times height. And again, the most important thing to think about is the fact that the base does not have to be the bottom, but the base and the height do need to be perpendicular to each other. So if I'm going to use the 12 as my base, it's the only side I know, then the height has to be this 3 inches. It has to be the one that's perpendicular to it. It can't just be a length of the side or something like that. So at this point the video is going to pause. I want you to work out the area of the triangle here, answer that question, and then we'll go over it together. Okay, so hopefully you got that one right, but let's go ahead and take a look at it. Again, I always start off with my area formula, 1/2 base times height, and I'm just going to go and plug everything in. So my area is 1/2, the base is 12, and the height is 3. Now at this point I could just go ahead and punch that whole thing into my calculator, or I could start simplifying it kind of one step at a time. If I do that one step at a time, 1/2 times 12 is 6, and I'm still multiplying by 3, which means my area is 18, and since those again were in inches, that'd be 16 square inches. Last part here for triangles, let's just take a look at where that formula comes from. Here I've got a triangle with the base and the height labeled. What you'll see here is if I make a duplicate copy of it and rotate it around, it turns into a parallelogram. And so since a parallelogram is measured by base times height, a triangle, which is just half of that parallelogram, is 1/2 base times height. Next up we've got trapezoids. Now this is probably one that you do not know off the top of your head. And I really wouldn't expect you to need to know that off the top of your head. But what we've got here is a little more complicated. It's 1/2 times base 1 plus base 2 times height. Now the important things here, the bases are the two parallel sides. So when you see that, maybe that's base 1, that could be base 2, and then the height has to be perpendicular. It's going to be perpendicular to both of them. It can't just be one of the sides unless you know that the sides are perpendicular. So in this case, I'm just going to go ahead and start this one. Always starting the same way. I'm going to write my formula down. Sorry, I left my pen at school and they won't let me go get it. And then I'll plug in the numbers. So 1/2, base 1 is 3, base 2 is 7, and my height is 4. Now the video is going to pause here and let you kind of work that out, and then we'll continue. Okay, so something like this, just again remember you have to follow your order of operations. So area is going to equal 1/2 times 10 times 4, doing things in parentheses first, and then we can multiply left to right. So area equals 5 times 4, which is 20 square inches. Okay, we got one more shape to talk about here, and then we'll do a few more examples together. So the last shape we're going to talk about today is a kite. Now I have the formula for a kite up here. It's 1/2 times diagonal 1 times diagonal 2. One thing to know here is there's absolutely no reason why you can't just treat this like two separate triangles. If you look on this side here, you've got one triangle. If you look at the other side there, you've got another triangle. They're actually the same. And so if you found the area of one triangle, then the area of the other triangle, and added them up or multiplied by 2, you'd be in good shape too if you forgot that formula or couldn't find it for some reason. But if I were just to say that this diagonal was 4 and this diagonal was 12, this one's pretty straightforward to plug in. You'd have area equals 1/2 d1 d2, which would mean that area is equal to 1/2 times 4 times 12. And if I punch that into my calculator, I believe that comes out to be 24. I didn't put units on that, but if we said it's inches, then it would be square inches. So at this point, a couple of more complicated examples, and then I'll talk about the homework real quick. The first thing that I might do for you is give you an area of something like this. At this point, I'm not going to have you worry about perimeter. You have the information to find it if you want to. But if I wanted to find the area of something like this, what I need to think about is the fact that this is just split up, can be split up into two parallelograms. So I've got one parallelogram there, where the area is 1/2 times 40 times 28. And then the other one over here, make sure you're looking at the sides here. The 8 centimeters is the height and the 40 is the width. 1/2 times 40 times 8. Just find those both and put them together, and you've got your area of something like that. It could be a rectangle combined with a trapezoid or something like that, but whatever it is, just add up the two pieces. That should say 28. It just says 20. But for something like that, just find those two and add them together. Next up, we've got working backwards. So the question here is, what if I told you the area, but I didn't tell you one of the dimensions and asked you to find that instead? Is there any way we could use what we know or what we learned maybe even last year to solve for that? And if you've been following along and showing your work the way I've been showing you, we actually have been writing this equation out every single time. In this case, since we have a triangle, area equals 1/2 times base times height. I still know two of those things, and only one of them I don't know. So when I go to plug that in, the area is 15, 1/2, the base is 5, and the height we don't know, so we're going to leave it as h. Now what we've got here is an equation that we can solve, and there's a few options on how we actually go about solving that. But what I would probably do is start off by multiplying both sides by 2, because 1/2 times 2 cancels out. And so I get 30 equals 5h. And then I can go ahead and divide both sides by 5. And I end up with h equals 6. And since, again, we're in centimeters, 6 centimeters. So we can use a little bit of our algebra to help us out there. Now the last one, a little bit harder still, is this one right here. And so what we've got here is a trapezoid. You'll notice that the perpendicular symbol is already there. So again, I'm going to let the video pause here. Go ahead and work this out and answer that question, and then we'll come back and do it together. Okay, so at this point, hopefully you've got your answer. So we're going to start off again with writing down our formula. So because this is a trapezoid, we have area equals 1/2 base 1 plus base 2 times height. And so I'm going to fill in things I know. The area is 63, then the 1/2, base 1 is 4, base 2 is 10, and our height is x. We don't know the height. Next thing I'm going to do to get rid of that 1/2, I'm going to multiply both sides of this equation by 2. And that's going to give me, on this left-hand side, it's going to give me 126 equals 4 plus 10 times x. Then I need to simplify. So 126 equals 14x. And then I can just divide both sides by 14. And asking the calculator what that is, says that we get x equals 9, and since we're in inches, 9 inches. So we're combining a little bit of our algebra. Hopefully that's a good chance to review some of that algebra from last year and get ready for next year as well. But start off with the area formula. If you write down the area formula, plug in the numbers you know, it's going to turn into an algebra equation. So last thing here, the homework for this week is going to be posted up on Canvas. It'll be a PDF worksheet. You don't need to print that out by any means, but what I do need to see with every single problem is the shape drawn out and labeled. Include those dimensions and what you're trying to find, the area formula you used, and then all the work to simplify or solve that equation. Look at what I've done here. If yours doesn't look like that, I'm going to be asking you to redo those. And keep in mind, I need to be able to read these on the computer as well. So you're going to be taking a picture and uploading it to Canvas, but make sure it's legible.